we are going to talk about differences between rational and irrational numbers. This is on the real number system. Before that, let's see some of the questions that we can use to solve, or we can use the type of definitions to solve. So let's check the question first. Here we go. Say which of the following is or are rational numbers. Is that okay? So you have a set of P, set of Q, as well as a set of R. So they say which of the following set is or are rational. So let's get the definitions of. By the way, the book I'm using is A Plus series. So credit to Dr. Ishmael Adams. Now let's get the definitions of the rational numbers. Okay. So you need to know what a rational or who a rational number is before you can be able to tackle this type of question. Now when you say a rational number is something that looks like this. Is that okay? So anybody that you see by the roadside that looks like something on top, then there's another number at the down, then that thing is what we call a rational number, right? The top can be a number, an integer. If you don't know what an integer is, they start from both positive and negative numbers, including 0. Is that okay? Of course, the down one cannot be 0. If the down one is 0, then it's going to be undefined. It's not possible to divide any number by 0. Is that okay? So down here can never be 0. So what we are trying to say is that a rational number is a number that there's something on top as well as another number on down. Those numbers are what? Both integers, right? So maybe something like 1 over 2, 3 over 4, negative 1 over 3, and so on and so forth. So this is something that we call what? Rational numbers. Is that okay? Now let's look at the families of what? Rational numbers. Right? What I mean by the families of the rational number, I'll explain that in a few minutes. So which other forms can we use to what? Express a rational number? Right? So the first one will be what? A proper fraction. Is that okay? So as you can see, so the firstborn of what? A rational number is what we call a proper fraction. So what is a proper fraction? You have to make sure that that fraction also looks like something like this one. Is that okay? So this is very, very important. So a proper fraction is, by definition, is something that maybe the top number has to be smaller than the down one. Is that okay? So this is what we call a proper, right? Always the top number has to be smaller than what? The down one, right? So when you see anything of this nature, you can see that this is a rational, because by image you can see that there's something on top and there's another number at the down. Is that okay? Okay, so that is the firstborn for what? A rational number. So let's look at the one that follows. So it's an improper. Of course, that is the vice versa of what? The proper. And that's where the top number is what? Bigger than what? The down one, right? So maybe when I rewrite this one, that can be 10 over 1, right? Or maybe 5 over 2. Is that okay? Something like this. Always the top number is bigger than the down one. Now the third born for what? A rational number, or what we can call a rational number, is what? Mixed fraction. Is that okay? Mixed fraction or mixed numbers. So this is how it looks like, right? The name are not all that important, but the image behind the name is what you must focus on. So here you are having a mixed fraction, of course. So this is how it looks like. Wow, a whole number, and then there's a fraction attached to that number. So let's say 2 over 3, right? This is how it looks like, right? A mixed fraction. Of course, these numbers can vary, right? They can be a different numbers. Is that okay? Provided that they are just integers. Is that okay? Alright, so this is what we call a mixed fraction. The reason is that this mixed fraction can be converted to look like something like this. Remember that we are talking about rational numbers, and this is how it must look like, right? So but this guy here doesn't look like the definition that we know. Is that okay? So what we are going to do here is that there's a way of converting this one to look like something like on top, then there's another one down. Of course, what you are seeing here, there are 3. So if you know how to do this, you just comment down below, right? Okay, so of course you multiply this by this and add it to that, right? So this one give 9, then plus this one, that will be what? 11. So that will be what? 11 over 3, right? 11/3. So you can see that this guy has been converted to that form, and this is exactly how the rational numbers looks like. Okay, and then let's move on to the fourth one over here. So you are talking about the families of what? A rational number, those that we can really convert from what? Their own state to what? A rational number. And we know that this is how the rational numbers has to be, or has to look like. Now the fourth one that we are going to talk are integers. Is that okay? So integers, what are they? These are just a set of numbers, both positive and negative numbers, including what? 0. Is that okay? So when I have 0 at the center, maybe 1, 2, and then 3 here, and then -1, -2, and so on and so forth. Is that okay? So this is what we call what? Integers. But the question is that, do these guys look like what? The rational numbers? Can we call them irrational? Right? Look at the way rational number looks like. It's what? A over B, right? Something on top and then another number down. But here we are just having a single number. So but why are they saying that this is also what? A rational number, right? So the reason that we can rewrite this one to look like something on top, then another number at the down, by just dividing this one by 1, right? Just by 1, and then by 1, by 1, by 1, and then by 1, right? The reason is that any number over 1 is just the same number. Divide two products to just one person. The person takes all. Is that okay? So that is why we are saying that any integers can also be what? A rational what? Number, right? Okay, so perfect. And then we have the next person is what? Terminating decimals, right? As the name implies, it's just that the decimals has an end. Is that okay? So terminating decimal. So this is how they look like. Let me say 0.2, right? 0.2 or 0.5. Have you seen that numbers will terminate after the decimal point? Right, the numbers terminate after the decimal point. That's why we are saying terminated decimals, right? This can be 3.2. All these things can be converted to looks like what? A rational number. Is that okay? So like this 0.5, like this would that be 5 over 10, right? 5 over 10. Then this one will give me 1 over 2. Is that okay? So as you can see, this guy has been converted to this form, and then it looks like what? A rational. So of course now we can call it what? A rational. Is that okay? So that's the reason why they are saying that all these guys can be converted as to what? A rational numbers. And then the final one we talk about is what? Recurring what? Decimals, right? Recurring decimals. They are the numbers that keep on repeating themselves. Is that okay? So when I say 0.333333 like this, right? You know, this guy can also be converted to what? To look like something on top, and then there's another amount. And there's a way of doing this. Is that okay? Sometimes you come across something like 0 point like this. So it means that the dot is on top of that number. It means that that number has what? Keep on repeating itself. Is that okay? So there's a way of converting this one to look like a number on top, and then there's another number at the down, right? So these are the families of what? A rational number. So anytime you come across them, you can say that your father is what? A rational number, right? So something of that nature. How many are there? There are 6 in all: proper, improper, mixed fraction, and then we have integers, terminating decimals, as well as what? Recurring decimals, right? So there are 6 in all. Now let's go and check how to use these two or ingredient to solve the question we saw earlier on. Okay, so let's check that. Once again, here's the question, right? So here's the question. Okay, they say which of the following is or are rational, right? So first thing first, you must know what irrationals are. I've already explained that. So let's pick the first set, whereby you have p is equal to 2 root 3 as well as what? 5. Then you just need to check the members in that set, right? And are they rationals? Is that okay? So of course 2 is irrational, and then 5 as well is also irrational, because we know that the families of irrational integers are part, right? What about root 3? Can you do something about that? You cannot do anything about that. Therefore p is not what? A rational number. As you can see, can you see that? Alright, so perfect. Now let's check the Q. Q, you're having what? 7, 1 over 6. Of course, the first two are rational, so you can see straightforward. What about root 9? Root 9 can be converted. Is that okay? So the functions of the square root tell us that you can split that number into 2, based on my opinion, right? So that will give us 3. Is that okay? 7, comma 1 over 6, and then 3. And in fact, everybody there becomes what? A members of a rational. So, okay, so the II or the Q set qualifies. What about the third one? You're having R to be equal to what? X is greater than or equal to minus 3, and then less than or equal to 8. Is that okay? Now let's check whether the members within that set are rational. We are not giving any condition on x, whether x is an integer or x start from 0 point, or x is a member of a whole number, right? We are not giving any condition, therefore we cannot determine whether R is what? A rational. Can you see that? There's no way we can do that. Suppose we are giving a condition on x, that one for sure we can say that x, we can list the members of the R, and then we can conclude on that R is a rational or not. So in this case, we don't know anything about that. So that set is not a rational. So the only set that we are having to be a rational is what? Set of Q, right? Which is 7, 1 over 6, root 3. That tends to be what? Just 3. So the answer there is just what? B. That is what? I only. Is that okay? So thank you very much for watching our video. Don't forget to subscribe to the YouTube channel for more updates.